Great. So yeah, I'll be telling you a bit about R, introducing it. I will say that Dr. Hinia's talk on SPSS, she covered a lot of things that will be important to know, I think. You know, I'm going to be showing you how to do a lot of what, you know, she described in detail on R, but I won't go into all that description, you know, for the sake of time. So yes, let's pull up R. I'm going to share my screen. Let's find it. Okay. Great. So can everyone see that? I should be okay. Let me just.
Yep, that's great.
Okay, great. Now I'm not sure while I'm sharing my screen how to see comments or questions. So if you're feeling confident, you can chime in and ask a question. I won't mind the interruption.
I also have it open on my screen, so comments should pop up at the top, but if they don't, I can read them to you.
Oh, okay, great. So yes, as Dr. Hania said before, SPSS is more user-friendly. It's sort of the difference between Mac and I guess PC or like Linux. You know, SPSS is more user-friendly. R is more customizable. It's more flexible. It's free and it's open source. So the reason I think a lot of people are going through it is, yeah, for that flexibility and the open source nature of it. So basically, if people come up with a really useful statistical package, which has a bunch of different operations that will help you analyze your data, you know, if someone comes up with that, they can just put it online and then you can use it right away. So it's quick and easy, constantly updating and changing. It's just a little more complicated. Great. So yes, so in order to download R, I provided the links and I think they're posted on eClass right now. First, you need to download, as it says up here, you need to download R before RStudio. So R is the computer language and RStudio is the environment in which you can use it. And here it says, yes, you have to have already installed R 2.11.1 or higher. I'm not sure exactly what that means, but I believe the link I provided should allow you to do that. Then you go ahead and download RStudio, which is what you're looking at now. It's the environment that we use to work R.
I think it's also in the My Apps.
Oh, really? Oh, good. Okay. Based on how my apps has been working, I mean, it's been working okay for me, but I think some people have been having trouble. It's not hard to download online either. But if it's on my apps and that works for you, then go for that. So I'm gonna move forward here. I think because this is recorded, and I'm also going to try to post this script that I'm going through now onto eClass. It should be okay. If you are following along, great. If you're not, then later on you can sort of look through the script in your RStudio and sort of see how it's all working. Okay. So some basics. So what we're looking at are 4 different panels here in RStudio. So we're going to get to all of them today. First, though, we're just going to deal with these 2. So this is our first and our second panels that we're going to be talking about. So this is where we actually put in the code. You can also put in text, as I have done. You can use text by putting a number sign just here, and then it'll turn green automatically, and you can write whatever you want, and R will not interpret that as you asking it to do some operation. So if I put 1 plus 1, it will not give me 2, right? Oh, well, it did here because it jumped to this line, 1 plus 1. When I run that, it gives me 2. So as not to get ahead of myself, this is the code box where we type in an operation, and down here is the output. Down here is the output. So As I said, I put 1 plus 1 in here. I run it by doing Control Enter, or I think on Mac's Command and Enter, and that just runs the line of code. And the output box, it appears down here. It shows you in blue what you asked it to do, and then the output in black right underneath it. So that's the very basic way it's set up. You tell it to do something up here, you run it with Control Enter, Command Enter, and then it does it down here. So the next step is learning how to store operations into a string of characters or a character, a variable. Okay? So I've done it here. It becomes extremely important in R. Here's a very simple demonstration of it. In our language, this symbol is asking R to do something. It's sort of an operation, right? And basically what we're asking it to do is store this into this. So the arrow, you see how it's pointing to the X? I think that's sort of indicating that we're putting this into this symbol. Okay, so I'm going to run it, and I'm going to run this as well. And now if we look down to the output, we'll see, well, there's no output. And that's because we haven't asked it for any operation. All we're doing is saying in R, X is now going to be equal to 1 plus 1, and Y is now going to be equal to 2 plus 2. And you can see in our global environment, which is the third panel we're going to be talking about, it tells us the values of these numbers now, right? That X is 2 and Y is 4. This global environment just helps us keep track of everything we've done. So as we bring in data sets, as we create variables, it's going to just show it all there in the environment so we don't forget and make any mistakes. So now that X and Y are those things, we can run X plus Y, and we'll see it gives us 6, because R has now recognized that X is 2 and Y is 4. Right? And this can get as complicated as you want. I've just done a little demonstration here. If we run this in the environment now, we can see X is no longer 2 because we've made X something else. Right? X is now, I think, 31. My thing is walking. Yeah, 31. So then, of course, if we do X plus 20, we get 51 because X is now 31. So this is a very simple thing, but it introduces our first sort of bit of code or operation that we're going to need to know, which is this arrow symbol.
Mike, you're cutting out a little bit. The sound is cutting.
Okay, 1 second. Let me see if I can. Let me try. Is this any better? Well, as I talk, you can let me know if it's any better, and if there are still issues.
It's better right now. Thank you.
Okay, good. Okay. So why don't we move on? Let's talk about getting data sets into R. Okay. First, we are going to have to download a few of these packages. Packages are, they're sort of groups of operations or functions that statisticians have put together that make our lives easier, right? So if we just, I'll just download all of these, and you'll see in the output, it's doing a bunch of stuff. You should look through these red messages. Generally, they can be error messages that will tell you something you're doing might be wrong. In this case, when you're downloading packages, sometimes they pop up and don't mean a whole lot for your purposes, okay? So I'm going to show you now the fourth box that we have. It's sort of our navigation window down in the bottom right. And I say bottom right because this is how my screen is laid out. Because everything's so customizable, you can move any of these boxes anywhere. But this navigation window here for me is on the bottom right. And here you can go to Files, Plots, Packages, Help, and Viewer. So on Packages, you'll see a whole list of these things, right? Because R is used for so many different statistical purposes. but you'll notice there is a psych package, which I've just downloaded, and it's listed here, down here, right? So this contains really useful operations for doing psychological statistics. So it makes sense that we would want it as we go forward, right? Now, in order to get our data set into the global environment, right, the environment, so that we can manipulate and do statistical analyses in R, we have to download the data set to our computers, which I know we've done if you were with us during the SPSS talk. So then we have to navigate to it in our navigation window, okay? So I'm gonna go to Files, which pops up all my computer stuff. Don't look too closely at my, my other folders. So find the folder that you have downloaded your data set to. So this is where mine is. So I've navigated there now. I see it here, it's study, I'm gonna put in study 2 text. So we're gonna hit more. So up here, there's the more button. And this will allow us to set this as our working directory. So we can't just automatically pop this into R. Once we navigated to the window, we have to say, okay, R, identify this folder as your working directory, and then anything in that folder, you'll be able to put into R, okay? So I'm gonna set it as my working directory. You'll see in the output that something happened, set working directory, and then it gives us the specification for what folder on my computer it's in. So once we've done that, we can put it into R. I know there's a bit of a learning curve for R, but once you get used to it, this is actually quite simple. Basically, you do have to store the data set as a string of characters. So I'm going to store this data set as my data. We're just going to call it my data. It could be anything. Caps do matter though, so be careful to try to pick simple things that you'll remember, okay? So I'm going to call it my underscore data. We're going to use this store function that we already learned about. And we're going to put the data set in there. Now the function to read a text file is different from an Excel file or a different kind of file. It's read.dlim, right? So let's go ahead and run that. Again, if you look in the output, there's no output because we're just storing it, right? But if you look up at the global environment, you can see suddenly we have the data set there. So I'm going to hit view my data. The operation view with a capital V, well, you'll see what it does. So it just lets us look at the grid. Look at the grid very clearly. So this is the data set, the one that you will be working with.
Okay, so it didn't upload into my global environment.
It didn't upload into your global environment?
And can you slow down a little bit also?
Yes, of course.
Thank you.
Did you, yeah, where to start? I guess the first step is setting your working directory and making sure that's where the file is.
Did that?
Okay, great. The next step would be, yes, making sure that this code is correct. So, so the important thing about the code here is, yes, read.dlim is the function. So, yep. And then open bracket, and then the exact name of the text file has to be in quotation marks.
Yeah.
Yeah.
Mm-hmm.
Close bracket, and did you run it with Control Enter?
Control Enter.
Or Command Enter if you're on a Mac, I think.
Okay. So.
There's also a button up here, yep. A Run button.
Okay. Tried that. Yes. Thank you.
Great. Okay. Are there any other questions? Any other troubles or anything that I can help troubleshoot?
No, it's good. You're going pretty fast. So
okay.
I might need to. I know that it's a lot of stuff and you want to get through it, but I need to.
I'll slow down for sure. Okay. Great. So at this point, if we have the data set in there, don't worry, I'm not going to be using this data set for analyses so as not to like influence you in your work. But I just wanted to show you specifically how to get this data set into the environment. So yeah, just a quick review of what we've done is downloading R, right? We have to download the language before you download the environment of RStudio, and that will help you download it. If you, this box is where you type in the code, where you tell the computer to do things. And this is the output down in the bottom left here. Let me just, which will give you the answers that you're looking for. It'll give you the output of what the computer has been asked to do. We have our environment up in the top right, which is where we stored our, it shows us the data that we've stored in R so far, any variables that we've made so that we don't lose track and get confused. And then in the bottom right, we have our navigation window, which does a bunch of things. When we start making graphs and plots, it'll pop up here.
And just to confirm, because I think this is a really important point, that if you want to enter a statement that you've put into that top window, you don't just hit enter, you have to hit, if you're on a Mac, you hit Command Enter, and if you're on an IBM compatible computer, it's Control.
That's right. And we call it running. You're running that line of code. And there's also actually in R, there are a million ways to do everything, which is what's so frustrating, confusing, and also convenient in some ways about it. It's very flexible. So there's also this button up here that just is run. So if your enter key isn't working, then you can still use R, don't worry. You just hit run on that line of code. And remember, if you want to put something in the code to leave a note for yourself, say you've got, have some very complicated code and you want to explain, why you've put this here, what you've done, then you put the symbol, the number sign symbol or the hashtag symbol there, and it will turn it green, and suddenly it's no longer going to get in the way of you running operations. It's just there as a note. The other thing is you can run more than one line at a time. So basically, if you want to run both of these things at once, you just highlight both and then hit your Control Enter, Command Enter, or the run button here, and it will do both at once. Yes, I forget. It's hard to get used to this language. At first, it's a little befuddling, but once you spend a little bit of time, it becomes, more second nature.
So can I ask one more question then? Under where you entered those libraries, did you have to say Control Enter to have those uploaded?
That's right. Any code you put in here, in order to make it do anything, you have to run it. So yes, Control Enter for all of these. If you were to just hit Enter, it would just do this, like put a space, kind of like a Word doc, right? Where you just sort of bump the text down, but it's not going to actually ask the computer to do anything.
Just complicate things. Mine says that there is no library car, no library psych, and no library ggplot.
Okay, it says that there's a warning message that says they don't exist.
Yeah.
Interesting. Well, yeah. I would try to go to in our navigation window. Let's go to packages.
Yeah, they're not there.
And they're not. Are there a lot of packages there, or are there just no packages?
Lots of packages.
There are lots, and they're not there.
Mm-hmm.
Okay. I think if you go to install here, a window will pop up.
I see that.
And this helps us find packages. I think
Yeah, I
Anyway,
see.
I think, so
So
try typing
separate.
in psych maybe.
Yep, I can actually add them here. That's very helpful.
Yep, and that's a way to install them into the computer, which is different from then putting them onto R through library. Like it's
Mhm.
different from downloading them into your R session. Once it's installed on your computer, then you're able to put them into your R session. So this is the boring, complicated stuff. It's funny, once we then get to the analysis, it just is like that. But this is the stuff that takes a long time, gives you a headache. It's actually just getting it all together.
And so when you try to upload it and it says, do you want to install the sources? Then you have to write yes, control, or yes, command, return.
Has it popped up? Is it a window like this that's popped up, or is it something
So
that's?
I've done that and I did install. And then I
Mhm.
have a question that says, do you want to install from sources the packages which need compilation?
Right.
Yes, no, cancel.
I would say yes.
Okay, and where do I say that? In the top or in the bottom?
Oh, has that come up in the output, or is that in the?
Came out in the output.
Well, that's strange. Are you able to now do library psych, or is it not? Is it not working?
I did all three
Mhm.
simultaneously because you can separate them by commas. Uh, and it said it installed all three. Um, and then it asked if I wanted to install from sources the packages which need compilation. And that would be all three, I think.
Yeah. So if that's in the output window, as
Yeah.
I'm not entirely sure, you might now be able to simply run the packages without having to take any further action.
All right.
So you might try that. If it doesn't work, then it might take a little more figuring out in
Okay.
terms of installing packages. Again, because R is all online, there are a million forums that will give you advice on how to handle error messages and stuff like that. So sometimes it takes a little bit of Googling to figure out things like this.
Okay. Thank you.
Okay. I also want to show you quickly, since we're on the topic of troubleshooting, there is a way to have a help window. Now, often it's not super helpful if you aren't already versed in R, but if you just hit question mark and then I think psych packaging, is this so I want to know what psych package is. I want the help window. I hit question mark, psych package. I've run that and automatically the help window popped up down here in my navigation window. And it's going to tell me about this psych package. Gives you a description. Now these are very long and often very confusing. So it's worth taking a look, but I think you might find more help online or by emailing me if you have any trouble, okay?
I
As
also
well.
want to say that the answer to the question has to be yes, and you have to type it in the top window, and you have to do command uh, enter in order to
Oh,
download or install those libraries.
wow. Okay, thank you. So that's good to know. So if those are not already installed for you, um, definitely do that. I think these are helpful packages. Psych especially. ggplot will be good for graphs. And car, I think there is something that I use that uses the car package. So do try to get those installed. Okay, should we move on as move forward into reading the data and stuff?
Yes, and a
Okay,
shout out
great.
to those heroic people who are sticking with us.
Yes, thank you. I don't know how many do we have? That's great.
We have Ahuva, Amanda, Leah, and Sonata. Yay!
Thank you. Okay, let's keep going then.
Nope,
Yeah.
we've lost one already.
Nah. Well, let me know when we should maybe pause and resume at another time, or I guess we'll just record
No, I
through.
think we're going to record, so we're just going to keep going.
Okay, let's keep going. So we've taken a look, we've read the data set into our environment, and we've taken a look at the data. It all looks good. So now let's look at just some basic descriptive statistics of the data set. This was in the psych package. This is one reason that we needed that package. It's describe. This is the operation. And then in brackets, we have the data set that we want to have descriptive statistics for. This is sort of the structure of a lot of operations, right? It's what you want it to do, and then in brackets, what you're doing it to, and in what way, right? So let's just run this, and you'll see in the output, it says describe my data. That's what we asked it to do, just down there. And then here we have all of the descriptive statistics that it provides, right? We have the N, we have the mean, we have our standard deviation, our median. I'm not sure. Trimmed. We have our minimum and maximum of the number, right? And the range there, skew, kurtosis. So standard error, I suppose. So it gives us descriptive stats. I put any questions so far here. I probably should have put it a number of times, but I'll just keep forging ahead. Of course, if anyone has any questions as we go, let me know. So I don't want to use the same data set that you're using. So I'm going to use one that's actually installed in base R. It's about flowers. So it's called Iris. It's specifically about irises. It tells us the length and width of their petals, the length and width of their sepal, I think it's pronounced, which is sort of the green parts of the flower, the green leaves. And it tells us what species. So there are 3 different species of iris: setosa, versicolor, and virginica. So that's the data set we're going to be demonstrating some of this on.
Can you post that in the chat so that we can maybe upload it?
Yeah, so that should come automatically with R. You don't have to upload it.
Oh, cool.
It's sort of for teaching purposes. It's just there.
Oh,
So that's
great.
why I'm using it. Yeah. So great. I say, why don't we try looking at a histogram of one of the variables here in this iris data set. So here is the function. I'll go over it for you. I've used with. So with is a really convenient way just to say with a certain data set. So basically we're saying with this data set, we want to do this on this variable. Confusing, but as we go through it, hopefully it'll be a little more clear. So with iris, which is the name of our iris data set, right? We want to do a histogram. This is the code for histogram here. And then in brackets on this particular variable, which is sepal length in the iris data set. Okay. So I'm going to run that. And it pops up in our plot area here.
Sorry, could you repeat that?
Of course, of course.
Well, I'm still I just finished getting it to describe.
Oh, great, okay. So yeah, let's go back to the histogram idea. I'm not sure, I think this might be in ggplot2, that package, or it could just come in R. But so what we're doing here is we're asking to create a histogram of sepal length. Remember that is one of our variables, the length of those little green petals, you know, on a flower. And we want to do that with the iris data set, which is called iris. It's very convenient. So with the iris data set, we're doing a histogram of this variable, sepal length. Okay, and then when I hit run, in the output window, it just tells me what I asked it to do. But in the plots, it brings up our plot here, our histogram. So if I hit zoom, which I'm going to do, we can zoom in and get a good look at it. Now it's it looks pretty good. This data set is kind of perfect, so everything is going to be very significant as we go through it all, which is not at all what you're going to be working with. Okay, so that's a quick way to do a histogram. Graphs in general, I found, can be a little confusing on R. If, maybe before Monday, I'll try to find a way to do a sort of more complicated graph and at least have that code for you. But it can be a little tricky. Dr. Hinney suggested using PowerPoint. I think that's not a bad idea as well. So we've described the data. We've taken a look with quick visualization. Why don't we start looking at actually running an analysis? So running on ANOVA. To do this, we do need to take a look at the data. So exactly in the same way that in SPSS, we needed to make sure that the variables we were looking at were coded properly as either continuous or categorical data. We need to do that same thing in R. So it's already stored in a certain way. So let's just take a look at how it is stored in R to see what we need to do to those variables. So this is the code for that. Structure is what the STR stands for, structure. So we're looking at the structure of the iris data set, because remember, that's what our data set is called. Okay, so I'll run that. And here we go. You'll notice that NUM is what's listed after length and width of the sepal and the petal. And then species is actually a factor. So this is actually stored correctly. Species is a categorical variable, so factor is what we want it to be in R. These other two are continuous. So numeric is what we want it to be in R. I think integer is also okay. I'm not entirely sure on how R will tell the difference between those different kinds of data storing. But for now, let's just look at numeric and factor. So this is stored correctly. But I know the data set you'll be using isn't necessarily stored correctly. So I'm going to look at the structure of that right now. So I've run the structure of my data, remember, which is what we've called the data set that you'll be using. And you'll see that it's all stored as INT. I think that means integer, which I believe it treats in a very similar way to numeric data. So it's all sort of treated as continuous variables, except for condition, which is treated as a factor. Okay, so this is actually correct, right? Condition is a factor. Remember, it's potato, kalimba, 1M64, not continuous data. Some of these are correct, right? Age is not categorical. Neither is father or mother's age. But something like gender, female here, should be categorical, and yet it is not. So I'm going to show you quickly how to change that. It's this code here. Specifically, we're looking at female. So I'm going to explain how this works. We're introducing another important sign in R. This one is our money sign. Okay, so we've looked at this sign, which tells us to store something into another thing, essentially. Now let's look at money. So my data is our data set. Money means within that data set. And then we list the variable that we want to look at within that data set, which will be gender, called female in our data set. All right, so within this data set, within this data set, we're looking at this column, right? So my data, money, female, and what we're storing into that, in other words, the way that we're changing my data, money, female, is we're gonna factor my data, money, female, right? So all we're doing is we're factoring this column within this data set. Okay, so I'm going to run that. And then if we check the structure again, which I'll do right here, you should notice that, yeah, female is now being considered a factor. Okay, so it's important to go through your data, figure out which variables should be categorical, should be considered categorical, and which should be considered continuous, and go ahead and factor those data that you want to be considered categories. If you want to switch it back for any reason, this is the function we use, as dot numeric. Right, so where here we took female in my data and we factored it. Here we're going to take, oh, I wrote gender, let's do female. Let's just take the same variable and let's turn it back into a numeric, make it as a numeric. Okay, so I'll run that and let's look at the structure. And yeah, we've made it wrong again. It's now treated as a continuous variable. Okay, are there any questions about that, or should I move on to the ANOVAs?
I think you're good. It's just you and me now.
Excellent. Okay.
But that's good because since I don't know what I'm doing,
yeah,
I can sort of pace you.
Great, and ask questions too if any.
Yeah.
Okay, so we've dealt with the structure of the data. We factor what needs to be factored. Now we get to run ANOVAs. So I'm going to give you the code here. The basic operation is simple. It's AOV. AOV. So I'm going to call this ANOVA. I just chose that.
Okay, so this is the name of the analysis, the word ANOVA.
Yeah. So
I could call it petal length.
You could get petal length. You could call it anything, literally anything you like. I suggest using something that is not a function in R because it'll get a little confusing. But make it simple, short, and easy for you to identify and to know exactly what. That's what I'd suggest. So I've just called it ANOVA, all caps there. And what we're going to store in that arbitrary name is this function. So AOV, and then open bracket, of course. And then we've got our dependent variable first. And what separates our dependent variable from our independent variable will be the tilde, this symbol. Okay. So we're interested in petal length across species. So that's our IV.
Where is that on the keyboard?
Oh, good question. It's right. It should be under your escape key, and you have to hit shift. So next to the 1 and under the escape key.
Oh, there it is. Thank you.
So that actually also becomes an important key, which I don't think I've ever used in anything else. So.
No, I've never. It's like, where is that? I know I had that.
And then you also have to specify the data set. Okay, so data equals iris. That's the name of our data set. So we're storing this ANOVA into this name, and the dependent variable is petal length, the independent variable is species within the data set of iris. Okay, so I'm gonna hit Control Enter, and you'll notice it will pop up in the environment. So you can imagine as you're doing a lot of analysis, this environment can get very full. So it'll help you keep track of what you've named things and whatnot.
And so it's the dependent by independent.
Exactly.
Tilde species.
That's right.
Okay.
So we're interested in petal length across species. Okay, so I ran it, and in the output, all there is nothing. It's just what I asked it to do. And that's because we're just storing it into this name. But once we've done that, now this name we can do whatever we want with our ANOVA here. And this function summary gives us the output that we might want. So we're going to do the summary of this ANOVA that we just ran. So I'm going to run that. And here we go at the bottom, our output. So it gives us a box that I'll walk through quickly. We have our degrees of freedom for species, right? The sum square, our mean square, our F ratio, and then our p-value, the all-important p-value for this assignment at least. So this will give you important information when you're writing up the APA style sort of summary, right? For your F values, your degrees of freedom, and your p-value. We can see it's significant. It's very, very significant. That's very, very small. So there is a difference between species, believe it or not, of irises and petaling, not surprisingly maybe. Now, say we want to add.
Sorry, can I pause for a second here? So if I was going to write this up, then the degrees of freedom for the error that I was talking about in the SPSS is the degrees of freedom for the residuals. And the degrees of freedom for the effect is the degrees of freedom for species here.
Yes.
Just so that we're using the same language across the two.
Right. That's exactly right.
And the p-value, which is 2 to the 16th, is actually 0.000000002 with 16 zeros.
Yeah, this is the smallest number you'll see in R, really. Basically, it's 0.
Yeah. So when you report that, because it's so small, you would report it just as p less than 0.001. Normally, you report the p-value exactly, but here you would report 0.00, less than 0.001.
Yeah, exactly. I don't think we're going to be having that problem with this assignment.
Not at all.
I think it's going to be hard to get significance with this data set, but hey, it would be great.
People can be creative.
Exactly. Cool. So that's the summary of our first ANOVA. Now that's a one-way ANOVA. It's very simple, but it's very easy to add independent variables in R. All we do is let me see how I should. Yeah. So I'm going to call this one ANOVA 1. Just not very creative, but you could call it interactive ANOVA or whatever you care to. And it's the same function, AOV. We have our same structure with the dependent variable separated by our independent variables using a tilde, right? So all we've done is we've added an asterisk and then another independent variable, petal width. The asterisk indicates it will be an interactive model. So we're looking at the interactions. If you ran a plus sign, it would not be. So if you're curious about the interactive effect, you would want to use this asterisk. and of course,
spaces don't matter, right? So you can put spaces before or after the commas, but you don't have to.
That's right. I don't think it doesn't think about spaces usually. This is exactly the same, even though there are no spaces. Great. So I'm going to run this, which is the same ANOVA, but we've added an independent variable and an interaction model here. We've added petal width. So it should pop up in our global environment, and it did.
Okay, give me a second because mine didn't work. Species, petal.width, comma, data, here.
Yes, it's frustrating because very specific punctuation matters. So, you might get a lot of errors. Just go back over and make sure everything's.
Okay, all good.
Let's do a summary of that. Remember, summary will give us the output of the ANOVA that we just built, right? So let's look at the output here. You'll notice that we've now added petal width, and we've added an interaction here between species and petal width. All of the same information is provided for each of these, the degrees of freedom, sum squares, mean square, F ratio, and the p-value. Now, like I said, this data set is sort of perfect, so everything is significant. The species, of course, main effect, we know that's significant, and it is when we add this interaction. Petal width, we also have a significant main effect, meaning that the petal length will be different depending on the petal width, as one might imagine. And we also see an interaction effect. So the relationship between petal length and petal width differs by species, might be a way to interpret that.
Great.
Great. And I have another, it's so easy to add IDs. I just did another one where we added another independent variable. Are
you going to show us how to get the means from this?
The means from this ANOVA specifically?
From the interaction.
Means from the interaction. I can see if I can, yeah, I don't think I did include that. I can see if I can.
Okay, that's great. Thank you.
Means for interaction. Okay, great. So let's just skip this because I think we get the idea. That's how you run an ANOVA. It's this structure, and you can add more independent variables using this asterisk if we want it to be an interaction model. And so why don't we hop to our analysis of covariance on ANOVA. This is a little more confusing in R. I found it actually hard to find exact way to do this in all circumstances. But here I can show you how it did end up working. It is the same function. It's the AOV function. And the dependent variable is going to go here. For some reason, I've put sepal width as our dependent variable. This is what we're going to be interested in looking at. The tilde will separate the dependent variable from the independent variables and the control variable. Okay. So what I read is the control variable, the continuous covariate here, comes first. So that should be sepal lengths. They were controlling for sepal length. It doesn't really make sense why we're doing this in this data set, but let's say it is. And then species will be our independent variable, our categorical independent variable. So when we run that, it should come up in our global environment, which it does, ANOVA. Instead of using the summary function to read it, to read the output, we're going to use this function. It is confusingly called ANOVA with a capital A and then lowercase nova. The reason we're doing that is because we can specify the type of sum of squares. I won't get into the weeds on this, but it begins to matter when you're talking about the order of that you input the independent variables begins to matter if you're using a type 1 sum of squares, which is what the summary application that we used before, this operation, it's what it defaults to. So this way we can change it to a type 3, which I believe is actually what SPSS means. So this way you can get the same results as SPSS. So I think I ran this, and you'll see it looks the same, this ANOVA function. Again, we have significance everywhere. The covariate did make a significant effect when it was added to the model, and there is a significant relationship between sepal width and species. I want to use this quickly to look at the data set that you'll be using to sort of show what the researchers did. It's not exactly what they did because I haven't cut the participants and omitted the experimental condition. But I'm going to show you how they controlled for father's age in their, ANOVA, with the dependent variable being age and looking at that across conditions. So we're now using my data set, right? This is the data set that you'll be using. We're going to call this ANOVA2. AOV is the operation. And remember, the covariate is the first after the tilde, then followed by the categorical independent variable of interest. So I'm going to run this. And if you look down at the output, you'll see that, yes, father's age actually did have a significant effect on this relationship between age and condition. And I imagine Simmons saw this and then further manipulated it to reach significance. This is not quite significant yet, right? But father's age did have an impact on this model. Anyway, I hope that, I know it's a little confusing, but again, I'll attach this script and you'll have access to some of this code should you want to use R in some of these analyses. I found that the code doing ANOVAs in SPSS is much simpler and easier than in R.
This is actually really, I found it really interesting and helpful. It's not as intimidating as I thought.
Good, yes. It shouldn't be intimidating. What I find a little scary though is this output looks exactly the same as the summary output.
Yeah.
And it can be totally different. One can be totally meaningless if you're not confident in how you done it. So I do maybe recommend that people starting with R, sometimes it's a good idea to cross-check with SPSS, just to make sure you're sort of, not making this sort of systematic errors. Okay, so I'm gonna move on quickly to some easy strategies with sort of code to exploit some of these researcher degrees of freedom that we will be using. So the first is participants, omitting participants. In R, it's pretty simple. You do, essentially what we do is we create a new data set with, of the old data set minus a few participants. I'll explain now. So say we want to cut the very final subject in our iris data set. I should say flower in our iris data set, the 150th. What we do is I'm going to call our new data set iris cut because we're cutting. And we're going to store in that the iris data set minus the concatenate, which means the combination or the linking together of whatever is in this bracket, which is 150. Remember, we're omitting our 150th flower. Now, the reason these square brackets are here is because it's a row column setup. So before this comma is the rows, and after the comma is the columns. We're not doing anything to the columns, so this is blank. But we are minusing, we are omitting the 150th flower. Okay, so when we run that, and we're going to view it, remember our view function, operation, you scroll down and there are only 149 now. So we've just knocked off that participant.
So can you repeat that again, please?
For sure. So the line of code, we take our iris data set and we are going to do something to the rows and columns, right? Which is why we have the square brackets. What's in left of the comma is the row. So that's what we're going to do to the rows. And what's to the right of the column is what we're going to the right of the comma is what we're going to do to the columns.
So you could omit a column, which would be a variable, or a row, which would be a participant.
That's right.
Great. Thank you.
So we're just chopping off the 150th row. That's all. And the researchers before they the article we read, they were talking about how you might stop, wait until you get significance and then just stop testing participants. We can kind of mimic that by saying, what happens if you chop off the last 5 participants and they never existed? So that's sort of how that works. And just to show you that it's very flexible. Say we wanted to remove randomly the third subject flower and the 101st to 150th flower. So this is how you do it. It's exactly the same, except when you want to do a larger range, you just put the colon between the two numbers. Okay, so minus the concatenate of 3 and 101 to 150. So I'm going to just do that really quick. And you'll see that 3 is missing here. And it ends at 100. So that's all. Say, I'm not going to run this now, but we have these new data sets, right? Iris cut 2 and iris cut.
Sorry, I have a question.
Yeah.
My apologies.
No.
So you actually have 2 commas now between your square brackets.
Yes. Good to clarify this. A lot of brackets within brackets. That's something that we have to get used to in R. So we have our square brackets, which is the row column setup. And then within our row setup, we have more brackets, which is, you know, what are we going to be cutting? So there could be 100 commas in here saying 3, 6, 8, 10. Those are just the rows that are going to be cut because they're in those circular brackets, right? This is the operator on that is minus C, meaning subtracting the combination of everything within that bracket. Okay, so those commas don't speak to rows and columns. They just are separating which of the rows are going to be cut.
So just as a comment, when I ask it to view the data set, it tells me there's an error and I can't find the function view. But when I go over to the global environment and I double click on iris cut, it opens the data set in the window on the top left corner.
Okay, perfect. So it should, that's great. Yeah, I noticed that too just now.
Yeah, it opens a new, it's like it opens a new folder inside that window.
Which is exactly the same as the view function.
Yeah.
The view
so for some reason, it won't let me type the view function, but it does let me do this.
Great. So, you know, there are many ways to do the same thing in R, which is really good. The view, I'm not sure why it wouldn't work. Is it a capital V by any chance?
Maybe.
It should be capital V and then IE.
Oops.
So.
That's it.
Okay, good.
Thank you.
You're welcome. But yeah, that other way of just clicking on the environment is totally, it works fine. Excellent. So now that we have these data sets without these participants, you just run the same ANOVA that you ran before, but plug in the new data set, right? So instead here of doing iris in your ANOVA line of code, you would do, you know, whatever you called your new data set without those participants. And I think you'll find that you know, especially if you pick the participants wisely, you'll find the p-values change. Wisely, unethically, what, you know, whatever you want to call it.
Okay.
Okay, so this is our last researcher degree of freedom, I think, that I haven't touched on. Well, here's another one. How to cut out sort of experimental conditions. I'll show you a quick way to do that with some functions that are going to be useful if you like R and are going to go forward with R. The functions are subset and rbind. So just to describe what we'll do before I'll show you the code is we're going to take our data set that we have and we're going to make 2 new data sets that include 2 flower species that we want to consider, okay, that we're interested in. Say we're trying to cut this 3rd flower species, right? So we'll make 2 new data sets, 2 new subsets of the data with the 2 species that we are interested in. And then we'll use a function just to stitch them together. And then we'll use that new data set in an ANOVA, and voila, we've omitted one of the species. So this is how to do it. To make a data set subset, looking at only Setosa irises. This is one of our species. We're going to call it iris setosa. Then we're going to use the subset function, and we're going to subset what's in the brackets here. The data set is iris, right? So we're subsetting that data set, and we're specifying the species has to equal or has to be named Setosa in quotation marks.
So the two equals means that the value has to be equal to?
Yeah, it's honestly that it's a little confusing what 1 equals versus 2 equals mean. I was taught don't put 1 equal sign in general because it can confuse things.
Okay,
In
because
particular,
data set is equal, so data equals iris, and everything else is double?
Yeah, this is what I've been taught.
Okay.
I'm not entirely sure about the double versus single.
Okay.
Basically, you find these useful codes. I think they differ from package to package how they structure them. But so once you found it, you can
just keep using it. Yeah. Got it.
Okay. So so basically, the species name Setosa, we're going to make a subset of the data. So I'm going to just run that right now, and we'll view that too. And you'll notice that this is just Setosas. So it works. So that's the first subset we're making. Then we also want a Virginica subset. So it's exactly the same line, except instead of Setosa, we're going to do Virginica, and we're going to name it something else so we don't get confused. So I'll run that, and voila, we have our Virginicas. And then finally, now that we have the two that we're interested in, we just want to merge them, right? So here's a way to do that. Using the rbind function, I'm calling this data set iris 2 species instead of the 3 species that we usually have. And you just rbind the data sets that you include in the brackets separated by a comma. So it's very simple. Rbind these 2 ones that we just made, and this is what we get. So you'll notice that it's the same data set minus versicolor, which was our 3rd species. So that's how we subset and rebind data to omit experimental conditions.
Sorry, I'm still just finishing the last subset. So now to bind.
Yes.
Okay, so, oops, iris. So 2 species is the name of the new. So you're using a thing here where, how are you making decisions about what you use as capital and what you use as small letters in the naming?
Yeah, that totally one's own idiosyncratic way of doing it. You can call it whatever you want that makes it easy for you to recognize.
And before rbind, you have a dash. Oh no, okay, never mind.
Yeah, this is
just the 1 dash from that command. Got it. Got it. Okay, that worked.
It works great.
Here it is.
Excellent.
That's cool.
Yeah. So so there are a lot of ways to play around with the data in R. And the nice thing about making sure to store it in another thing of a different name is you're not overwriting anything, right? You could store it in a data set of the same name, but that would totally overwrite what you had before.
Actually, it didn't work. When I look at my data in 2 species, I only have Setosa. And when I look at oh, it's because there's nothing in Virginica. Okay. Maybe I got the name wrong. Hang on.
Could be in the quotation. Oh, yeah, in the quotation marks, you might have spelled it incorrectly.
Virginica. Okay. Well, anyways, it's probably a spelling error.
Maybe. I also a good thing to highlight is really clocking which data set you are subsetting from. So here in Iris Virginica, you subset from the data set iris, the original one, because that has everything. If you were to subset from this, then it would turn up nothing because there is no Virginica there.
Yeah, iris cut actually only has 2 species.
Yes, exactly, because we've iris.
Okay.
Yeah, so I would just use iris because that has that's our original data set.
No, I did. I was just trying to find where the. There it is. Okay,
And
I don't know why it didn't work, but it didn't work. But anyways, I will play with it.
Okay. But I will say this does speak a little bit to how confusing it can get.
Yeah.
Because we make a lot of different data sets, and it's good to label them in a way that you're going to remember sort of what's going on, and it's good also to make notes like I have here, because as you go through your own code, it's so easy to just get lost and confused. What was that? What was this? Make sure you make codes. You make notes for yourself to make sure you know what's going on. Okay, so just the last thing I want to go over here is say we've done some p hacking and we get a significant effect. If there are more than 2 levels, it will not tell you in the output which ones are different from which, right? So we have to do post hoc pairwise comparisons. So I'm going to show you first a quick way just to look at means of y across levels of x, just to get an idea. So remember our width. Width means, with this data set, we're going to do some function, right? So with the data set of iris, we are going to do t apply. I'm not sure exactly why it's called that, but we're going to, I think it is because we're going to apply mean. We're going to look at the means of petal length, which is our dependent variable, across the levels of our independent variable. So I'll go over this again. In tapply, first we're going to put the dependent variable of interest. Then we're going to put the independent variable that we might know their significance, we just don't know which levels are different from which. And then we're going to put mean, just telling it, we're going to look at the means of these different levels, right? The means of this dependent variable across the different levels of the independent variable. So let's run that. And in the output, it shows us the mean of petal length across our different species of iris in our iris data set.
So what that says is that the commas, whatever the last function is applied to everything else separated by commas before it?
Whatever the last, oh yes, whatever this is, yeah, is applied to, it's the dependent variable of, it's the mean of the dependent variable across levels of this, of the independent variable.
Okay.
Okay. So the means of petal length across our species here in the output looks like Setosa's petal lengths are smaller than Virginica's. If we had significance, we might kind of guess, yeah, Setosa and Virginica are significantly different, but we don't know about versicolor, right? So this just gives us an idea. It's not going to tell us definitively.
So it's supposed to. Okay. Sorry, it's not working. So I'm just trying to figure out why it's not working.
Oh, okay.
Oh, there we go. Okay, I got it.
Good, great. This again, this is just an idea to get an idea of the different levels.
Okay, no, that's important. Thank you. And so now we're doing post hocs?
Yes. With iris, remember our with the data set iris. This is the function here, pairwise t-test. So we're doing a pairwise t-test, right? The same structure, you'll see petal length being our dependent variable, our independent variable is species. And the nice thing about this is you can add how you want to correct for family-wise error. I've chosen Bonferroni here. You could do none, which means no correction. I think you can also do Tukey. So there are a couple options for how you want to correct for error here. So let's run this t-test and see what we get. We get a little matrix. Again, I said it's a perfect data set. Everything is very significant. You know, all the species are significantly different from each other in terms of their petal length. If you know something about irises, maybe that's not surprising. I don't know. You know, you never know. So finally, I'm going to show you another way to do pairwise comparisons using actually our ANOVAs. If you have a longer, more complicated ANOVA with a lot of different categorical factors and different levels, then this method is going to be preferred because the function will just spit out all of the pairwise comparisons like that. So I built a little ANOVA here. I think I did it pretty randomly. Yeah, just, oh, it's the same thing, petal length by species. Remember, AOV is the function. Petal length is our dependent variable. We have the tilde separating it from our independent variable, which will be species. And then data is our iris data set. So we're going to run that. We're going to do a summary. And we see there is significance, but we know there are 3 levels of species. So how do we know what's significantly different from what? Well, we can use this function, Tukey HSD. So it is the Tukey correction for family-wise error. And you'll see when we run that, here's the output. Oops, sorry. We see that, yes, here we have the p-values. I've never actually seen it say 0. I think it basically it means yes, there's a very, very significant differences in based on species. And it's the same as what we saw in here, right? The nice thing about this is, as I said, if in your ANOVA you have a bunch of different variables and different levels, it will actually just spit them all out and label them like it has here. So you don't need to go and do a bunch of different tests. You just need to do the one and it'll tell you. However, just be warned, because Tukey does correct for family-wise error, which means it corrects for the false positive rate that can accrue when you look at multiple different comparisons. The more levels and the more variables you have, the more conservative it will become. So the harder it will be to achieve significance.
Same for the Bonferroni.
Yeah, for sure. The thing about the Bonferroni is because you're not doing it all at once, you could run 1 million of those tests. If you were p-hacking, of course, I would not, you know, this is very unethical, but you could run 1 million of these sort of individual tests. And that one line of code doesn't know that you ran 1 million of these tests. So it's not correcting for all of the little tests you ran. So yes, if you just put one big ANOVA into Tukey HSD, it's likely going to be very hard to achieve a significant value. Okay. So anyway, that's it. I know that was a lot.
Thank you so much. Yeah. I must admit that I haven't been able to get it to run any of the post hocs, but okay. I will keep playing with it. I'm not sure why it's so unhappy. And this has been really useful. Thank you.
Good. I'm glad. Yeah, I'm glad it helps the SPSS talk this as well. And yeah, like I said, I can send the script there, and if you want to post it and people can look at it and sort of.
Yeah, that might be useful. Thank you.
Yeah.
Thank you very much.
For sure.
And I apologize. I've taken you an extra hour over class.
That's okay.
So thank you for your time and for preparing this. It's very helpful. And I don't know how many others are going to try to do this. I'm probably going to end up spending the rest of the afternoon just trying to get the post hoc to work. So I don't know why it's not working. it's blue. It says everything's fine. It's not saying there's an error. So
What's not working? Is it?
it's just not giving me anything. It has a little plus sign. Does the plus sign?
Yeah. Did you close the bracket? Is the bracket fully closed?
Are there two brackets or just one?
Are you running the two key or are you running the pair?
The pairwise.
Yeah.
Oh, maybe there's two brackets. That's
yeah,
it.
It's probably.
That's it. That's it for sure.
Excellent.
It's like, you know, I'm like looking at it, and I can't see the missing. Now I have it. Well, I don't have it, but that's fine. I'm sure I'll find it.
Okay.
Thank you very much.
Yes, you're welcome. I'm glad I could hopefully help. And if I guess we're still recording. If anyone has any questions, we're here by email and stuff. So.
Yeah, and like I said, I'll separate out these videos so that we have a separate video on each approach, so that people can look at the videos. They don't have to look at them all at once, and it's easy for them to find the section that they want to get to. Yeah. This is a really useful program to learn. I think there's also an online tutorial for R somewhere that Raymond sent me.
There are lots, but there's one on Coursera. I think that's very good and free. So
yeah, so I'll also post that for people who want to learn more about this methodology. But this was really helpful.
Great.
Thank you so much.
Yes, for sure. Thank you.
And we'll see you Monday, I guess.
Yes. Yeah, Monday, right? Office hours.
Okay, just